All right, let's talk about variation problems, and there are several different types of variation. The first variation we'll talk about is direct variation. And so you're going to see these words. You're going to see something that says y varies directly with x, or y is directly proportional to x. And when you see those phrases, this is what it means. It means you have an equation that looks like this: y equals kx. And k is a constant of proportionality, and it's going to be your job to figure out what that constant is. So let's take a simple example. Write an equation that describes the variation s varies directly with t cubed. So we're going to say s equals k t cubed. And they didn't give us any more information, so that's going to be our answer. Okay, so now let's look at this. This says that s is directly proportional to t. So here's our equation, s equals kt. And we're going to now find k, because we know that when s is 18, t is 12. So I'm going to plug those numbers in. 18 equals k times 12. Divide both sides by 12. And I get k, reduce, and k is 3/2. So here's the equation, s equals 3/2 t. So now I can find any value of s given a value of t. Another type of variation is called inverse variation. And so when you see these phrases, y varies inversely with x, or y is inversely proportional to x, then here's the equation you have, y equals k divided by x. So direct variation, y is k times x. Inverse variation, y is k divided by x. So here's an example. V varies inversely with p. That means v equals k over p. Write an equation that describes the variation if v equals 1,000 when p is 400. Okay, I'm going to put 1,000 in for v, 400 in for p, and I get k is 400,000. So here's my equation. V equals 400,000 over p. So you can have variation with more than two variables. For example, if I have one quantity proportional to two or more, then that variation is called a joint variation. And I can even combine direct and inverse variation in the same problem, and that's called combined variation. So let's take a look at this example. R varies directly with L. So I'm going to say R is K times L, and inversely with A. So I'm going to go divided by A. Write an equation describing the variation if R is 0.5, L is 20, and A is 0.4. So let's plug in our numbers. 0.5 equals K times 20 over 0.4. Multiply both sides by 0.4. I get 0.2 equals K times 20. Divide both sides by 20, and I get 0.01 equals K. So R equals 0.01 L over A. That's an example of combined variation because we have both direct and inverse variation in the same problem. And variation applies to a lot of physics problems. Here's a classic one. If you have a spring that is suspended from a ceiling, okay, so this spring is like this, and then you attach a weight to it, well, the spring is going to stretch, right? Well, it turns out that the distance the spring stretches is directly proportional to the force, the weight. So let's write that out. D is K times the force. Distance is direct proportional to the force. So it says that a force of 30 will stretch a spring 10 centimeters. Okay, 10 is equal to K times 30. So that means K is 1/3. So here's our equation. D equals 1/3 F. Now we can answer the question, how far will a force of 72 newtons stretch the spring? So distance is equal to 1/3 times 72, and 3 goes into 72, 26 times. So that means that 72 newtons will stretch a spring 26 centimeters.